Hey everyone, and welcome to this first lesson on sets. So in this topic we're studying set theory, but we're not actually going to give a formal mathematical definition to sets, because it would probably be too abstract and too complicated to really be useful for anything. So we're just going to talk about them sort of intuitively. A set is just a collection or a list of things, and in a set, nothing is repeated. So I like to think of a set as a list of people who are invited to your party, say. So there are two mathematical notations for a set. First, you can write down all the elements of a set in curly braces. So this is one way in mathematics you write down a set. Say I want the set of numbers 1 through 4. We can write this as a curly brace and then list all the elements of the set, 1, 2, 3, 4, and close the curly brace. So that's a way to write the set of elements 1, 2, 3, 4. Another way to write down a set could be given a pattern and then put a dot, dot, dot. So say I want to write down the numbers 1, 2, 3, 4, 5, 6, 7, 8, and so on, and it counts and counts forever. So there's no stopping, and you can't write all the elements in the set. But it's a pretty obvious pattern. It just means keep counting. So 1, 2, 3, dot, 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 and then end the curly brace. This dot, dot, dot here means keep going forever. So that's a way to write the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Sometimes though, even with the dot dot dot, you can't write down an infinite set. So say I want to write down the set of all real numbers between 1 and 4. And by all real numbers, I mean on a number line. So if you think of a number line, let's draw a straight line, if I can. Oh, well, that's okay. Okay, so we have a number line. And then here's the number, say 1, and here's the number 4. And I want all the numbers between 1 and 4. Well, there's not really a nice pattern to that, right? It's going to include things like pi and e and square root of 2. But I can write it down pretty easily in a mathematical notation. So the way I would write that set is the set of x such that, and this colon here means such that, 1 is less than or equal to x is less than or equal to 4. So this here is the notation for the set of all real numbers between 1 and 4. Just like if you were making a list of people you're inviting to your party, order doesn't matter. So if I wanted to, I could write down the list of people I'm inviting alphabetically, or I could just write them as they pop in my head. So if I wanted to write down the list of numbers 1 through 4, one way to do that was 1, 2, 3, 4. But if for whatever reason they popped into my head as 4, 2, 1, 3, that's totally fine. It's the same list. So the same elements are members. And also, just like a list of people you invite to your party, you don't write down somebody's name more than once. If you do, that's a mistake. Right, so 1, 1, 2 doesn't represent a set because it shouldn't say 1 twice. So this repetition is, you can think of it as like a mistake. This set should be just 1, 2. So those are the excuse me, two ways to write down a set mathematically. But sometimes it's hard to even do that. And so you can also describe a set, well, or define a set just by description. So for example, let S be the set of all people who live in Iowa. This is an easier way to write the set than trying to list down every single name of every person that lives in Iowa, right? I mean, it's a fairly long list. And there's obviously no pattern too, because it's just people's names. So you could write down 3 names and say dot, 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 but it's not really clear what that list is. But if we say the set of all people who live in Iowa, it's very clear what that means. And you can grab a random person and say, yes, this person is in the set, or no, they are not in the set, depending on whether or not they live in Iowa. Or for example, B is the set of all black holes. Well, we haven't even discovered all black holes. And as far as I know, they aren't really named. So there's no way you're going to be able to write down a set of all the elements that are black holes, but it's pretty easy to describe this way, and you can also take anything and say whether or not it's in the set. Certainly the nearest black hole to Earth is in the set, it's a black hole, and certainly, I'm not in the set because I'm not a black hole. So take anything that you like and you can say it's in the set or it isn't. So the description works perfectly fine. And in case you're a visual learner, here's a picture. So here is a set A, and A is everything inside the red circle. And mathematically, we would write A as a curly brace and then 157, close curly brace. And the reason it has 157 is because 1, 5, and 7 are all in the circle. You could think of it as these are the guys that are invited to your party. And the numbers 2, 8, 3, and 4 are all outside the circle, so they aren't in the set. The set is just 157. These are the guys that if they showed up to the party, they'd get bounced. Or they wouldn't even get let through the door, I suppose. Well, that's all for the introduction to sets. I'll see you guys in the next lesson.